Hello, welcome back to my channel, and welcome to another statistics video recording. Today we are going to continue our lesson about confidence intervals. This time we are going to get into the proportion confidence interval formula and what it is, and how we're going to use it as an example. And then I'll show you how the TI-84 graphing calculator will do the work for us as well, given enough information. So, with that in mind, let's get started, shall we? Remember that to make a confidence interval, you need two numbers, the point estimate and the margin of error. For a proportion scenario, the sample proportion is going to be your point estimate, the first number. And then the margin of error is going to be equal to the z-score times the standard error. Now there are formulas for this. The z-score is simply the number that comes off the normal distribution. That corresponds to your level of confidence, which we'll be told to in the problem. And then the standard error formula is going to be equal to the formula that you see on the video right now. Multiply those two numbers together, you get margin of error. Now, having found the point estimate and margin of error, that's all you need to find the confidence interval. It's just the two subtracted and then the two added, your lower and upper limits. And then remember that the interval tells you that you're not 95 or whatever % confident that the population proportion will fall somewhere within those two intervals, those two limits. So with that in mind, let's now take a look at an example on paper with the formulas. Let's now do an example of finding a confidence interval for a population proportion. Here is the question. We do a survey among 162 students in a class, and we ask them if they've ever parasailed. And 47 of them say yes. And we're going to assume that this is a random sample of students, so we're going to say the sample size is 162, of which there are 47 who say, yes, I have parasailed before. And we're going to say that this is a random sample, again. So the goal here is to find the 95% confidence interval given the sample size of 162 and 47 successes. So first thing to do is to find the sample proportion. The point estimate is the sample proportion in this case. That's p hat, the symbol. And that's simply the number of successes divided by the sample size, which in this case, I'll just write it to 5 decimals, is 0.29012. Okay, so that's our sample proportion, the point estimate. This sample proportion is the number that's going to be in the center of the confidence interval that we'll make. And before we go further, let's also verify that this confidence interval, when constructed, will be a valid one. And to do that, we have to have a random sample, which I told you it is, and we also need to know that the number of successes and failures is large enough, generally larger than 15. Well, we've got 47 successes, and number of failures will be 115 if you subtract that from the sample size, and so the assumptions are all met. The successes and failures are both larger than 15. So now, the next step is to get the standard error. If you're doing this by hand, the formula is going to be equal to this. You find this quantity here, and then remember to take the square root of it. So using the 0.29, and then 1 minus the same number, all divided by the sample size of 162, and then finally remember to take the square root of it at the end. And I'll go ahead and tell you that the answer, again to 5 decimals, is 0.03566. Let's make those look more like sixes, shall we? All right, so we've got our point estimate, we've got our standard error. Now, next part of the interval is the margin of error. And for a proportion, that's going to be equal to a z-score times the standard error. Standard error we just computed. Now the question is, what is the z-score? Well, it's the number that comes off of the normal distribution that corresponds to the level of confidence, which in this case is 95%. Let's write that up here again. Now, for a 95% confidence interval with proportions, this number is worth memorizing, and I will show you later in just a little bit where this number actually comes from. But z equals 1.96. That is a number to use for a 95% confidence interval. Once again, in just a moment, I will show you how to actually get that number. But for now, just take my word for it. The margin of error is going to be equal to 1.96 times the standard error that we just found a moment ago. That number turns out to be 0.06989. Okay, so let's recap what's going on here. To find the confidence interval, remember we need two numbers: the point estimate, which is a sample proportion, and the margin of error, which we just found here. Once you've got those two numbers using whatever method you've done, that's it. That's all you need to find the confidence interval. So the confidence interval is going to be the sample proportion minus the margin of error, and the sample proportion plus the margin of error. And so using our numbers here, that's going to be the 0.29 number plus and minus the margin of error that we just found, which was the z-score times the standard error. So that's the minus, and then the same thing but plus. Yay, I got it all on one line before I ran out of paper there. When you find those numbers, you will find that the answer is 0.22023 for the lower limit and 0.36001 for the upper. Of course, we could use more decimals with the calculator. I'm just, for simplicity, showing it all rounded to 5. All right, so this tells us the 95% confidence interval is given by this range here, which is 22% to 36%. Now, what does this actually tell us? It tells us, going back to the question which was about parasailing, have you or have you not parasailed? It tells you that we are 95% confident, based on the sample, that the true population proportion of students that have parasailed is somewhere between 0.22 and 0.36. So any potential proportion number between those two limits is a possible likely value for the population proportion. That means it is unlikely that the true proportion is going to be, let's say, 15%, which is below this interval. It would also be unlikely to be, say, 45%, which is above the interval, because any numbers within the interval are likely, those outside are unlikely, with 95% confidence, of course. Now let's get to the question that I asked earlier, which is, how did we find the z-score of 1.96 given its 95% confidence? Here's how we do it. Like I said earlier, that number is worth memorizing, but let's draw our normal distribution, our bell curve. Now, when we find a 95% confidence interval, graphically that means that we put 0.95 of the curve in the middle, like that, and that means that 0.05 is left over. Has to be, because remember, the whole area under the normal curve is equal to 1, or 100%, and half of that is 0.025. And so that is the amount that goes in both tails. So the upper tail gets 0.025 probability, and so does the lower tail. So put another way, the probability above some z-score is equal to 0.025, or equivalently, the probability below negative z is also equal to 0.025. So now the question is, how do we find those numbers? Well, you can use a computer program or your normal table in the back of your statistics book. I'm going to show you how to do this on the TI-84 graphing calculator. Here's how we get the z-score. We do second vars, which will bring up the distribution menu, and because we are given a z-score and want to find the probability, we're going to go with the third option, which is inverse norm. And we're going to put in the number that we found, the probability, which is 0.025, and the answer is negative 1.96. Now, the negative sign, don't worry about that, you can just drop it because that's on the left side of the curve. But you can still use z is positive 1.96, just dropping the negative sign. That is where we get the 1.96 number from. And if you're using software of some other kind, just ask your instructor or see the instruction manual for how to use that. We have just walked through this problem here using the hand formulas. The question now is, how do we do this problem on the TI-84 graphing calculator if you so wish? That is what I'm about to show you right now. Here's how the graphing calculator will help us with this problem. We're going to go to the Stat menu, then go over to Tests, and the first 6 options are about hypothesis testing. We'll skip those. The next 6 options are about different types of confidence intervals. Now, because it's a proportion problem and there's just one sample, we're going to go with option A, one proportion Z interval. Now, to do this, we just enter in the numbers we're told. So we have 47 successes, that's for the X, and we have 162, the sample size, and the confidence level we're using is 0.95, 95%, and calculate. And then we get the answers of 0.22024, 0.36001, and you can see that except for some slight rounding, we get the same answers that we got by hand. The only difference being the lower limit is off on the fifth decimal. That's fine. That's just likely because of rounding. But if you have enough information to use the graphing calculator and you're allowed to do so, this is how you would do it. And that is how you find a confidence interval for a proportion. I hope this video was very helpful for you, and I hope you enjoyed this video as much as I enjoyed creating it. And please stay tuned for my next video on confidence intervals for a population mean. That'll be coming up next very shortly. Thank you very much and have a lovely day.